Picture a monastery in medieval France. The year is 1347. A young scribe sits hunched over a wooden desk, copying sacred texts by candlelight. His left hand grips the quill, moving carefully across the parchment. But something's wrong. The ink smudges as his hand drags through the fresh letters. The writing slants awkwardly. His cramped fingers ache from contorting around a tool designed for someone else's hand. The abbot watches from across the room, frowning. This left-handed tendency, he believes, is a sign of something sinister. The boy must be corrected. Now, fast forward to today, you're sitting in a coffee shop, maybe watching this video right now. Look around. In a room of 100 people, roughly 10 of them are left-handed. That barista making your latte, that student taking notes on a laptop, that businessman signing documents. 1 in 10, maybe it's you. Here's what's strange about that number. It never changes. Across every human population ever studied, in every country, in every culture, throughout all of recorded history, the percentage of left-handers remains locked at approximately 10%. Sometimes it's 9%, sometimes it's 12%, but it always hovers right around that magical 1 in 10 ratio. From ancient Greece to modern Japan, from medieval Europe to contemporary Brazil, 10%. That's not normal. That's deeply, profoundly weird. See, evolution doesn't preserve traits at stable percentages for tens of thousands of years unless there's a reason. Natural selection is supposed to be ruthless. If being left-handed offered no advantage, random genetic drift should have pushed the percentage toward 0 centuries ago. And if it did offer an advantage, the percentage should be much higher. But instead, left-handedness stays frozen at 10%, generation after generation after generation, as if something is actively maintaining that exact proportion. If you're settling in to listen to this, maybe getting ready for sleep, do me a favour and drop a comment about where you're watching from and what time it is. I genuinely check these, and there's something amazing about seeing Tokyo at dawn, London at lunch, and Los Angeles at bedtime all in the same thread. This is the central mystery we're going to unravel. Why has natural selection, that merciless sculptor of human evolution, the same force that nearly wiped us out 900,000 years ago, allowed left-handedness to persist? Most genetic traits follow predictable patterns. Blue eyes, red hair, certain blood types. They exist because they are either neutral or they offer some advantage in specific environments. But left-handedness doesn't fit that model. For most of human history, being left-handed has been a disadvantage. Tools were designed for righties, weapons were built for righties, writing systems flowed in directions that suited righties. In many cultures, using your left hand was considered unclean, evil, or demonic. The Latin word for left is sinister. The French word is gauche, meaning awkward or clumsy. In Arabic, the left hand is reserved for unclean tasks. For centuries, left-handed children were punished, beaten, had their left hands tied behind their backs to force them to conform. Even into the 1960s and 70s, schools routinely forced left-handed students to write with their right hands, often through physical punishment and public humiliation. And yet, despite thousands of years of cultural pressure, despite no obvious evolutionary advantage, despite living in a world literally built for the opposite hand, left-handers persist at exactly 10%. The question gets even more fascinating when you look at the evidence. We can trace left-handedness back through human history in surprising ways. Ancient tools show where patterns from left-handed use. Cave paintings reveal the handedness of prehistoric artists. Fossilized teeth from our earliest ancestors carry scratches that indicate which hand they used to hold food while cutting it with stone tools. The signal goes back hundreds of thousands of years, always there, always around 10%. There's a story here. a story that spans human evolution, brain structure, genetics, culture, and survival itself. A story about why the minority persisted when everything should have eliminated them. We're going to follow that story through time, from prehistoric caves to medieval torture chambers, from Victorian schoolrooms to modern neuroscience laboratories. We'll meet ancient left-handed warriors who turn their difference into a deadly advantage. We'll explore the peculiar way left-handers' brains are wired differently. We'll discover why some of history's greatest geniuses, artists, and leaders were left-handed. But most importantly, we're going to solve the evolutionary paradox. Why did natural selection not just allow left-handedness to survive, but actively preserve it at that perfect 10% ratio? The answer is going to surprise you. Before we can understand why natural selection preserved left-handedness, we need to figure out what handedness actually is. And here's the first surprise: it's not what you think. Most people assume handedness is simple. You're either right-handed or left-handed, binary, clean, easy to categorize. But your brain doesn't work that way. Nothing about human biology works that way. Handedness isn't a switch that's either on or off. It's a spectrum, a gradient that runs from extreme left-handedness at one end to extreme right-handedness at the other, with most people falling somewhere in between. Think about it. You probably know someone who writes with their left hand but throws a ball with their right, or someone who uses scissors with their right hand but deals cards with their left. Are they left-handed or right-handed? The answer is both. Neither. It depends on what they're doing. Scientists have a term for this: cross-dominance. It's when you prefer different hands for different tasks, and it's far more common than most people realize. Studies suggest that somewhere between 20 and 30% of people show some degree of cross-dominance. They're not purely right-handed or purely left-handed. They're mixed, using whichever hand feels more natural for each specific activity. Then there's the difference between hand preference and hand skill. This is where things get really interesting. Hand preference is which hand you naturally reach for when you're about to do something. It's instinctive, automatic, happens without thinking. Hand skill is which hand actually performs better when you test it objectively. And here's the crucial part: they don't always match. You can have someone who prefers to write with their right hand but whose left hand is actually more coordinated when you test it in a laboratory setting. How does this happen? Usually through forced switching in childhood. A naturally left-handed child gets pressured by parents or teachers to use their right hand for writing. Eventually, the right hand becomes functional for this task, but neurologically, deep in the architecture of their brain, they're still left-handed. Their hand preference was modified, but their underlying neural organization wasn't. This forced switching was incredibly common throughout most of human history. We'll explore the dark history of left-handed persecution later, but for now, just understand this. The 10% figure for left-handedness is probably an undercount. The real number of people with left-handed brain organization is almost certainly higher, maybe significantly higher, but cultural pressure has hidden them, forced them to adapt, made them invisible in the statistics. Then there's ambidexterity, which sounds impressive but is actually quite rare when properly defined. True ambidexterity means you can perform tasks equally well with either hand, with no preference at all. Most people who claim to be ambidextrous are actually cross-dominant. They use their left hand for some things and their right hand for others, but they're not truly equal-handed for any single task. Real ambidexterity exists, but it shows up in maybe 1 or 2% of the population. And interestingly, it often comes with its own challenges. Some studies suggest that truly ambidextrous people have slightly higher rates of certain learning difficulties, possibly because the lack of strong hemispheric specialization in their brains creates subtle processing inefficiencies. Evolution doesn't just randomly optimize for flexibility. Sometimes specialization is the better strategy. So how do scientists actually measure something this complicated? You can't just ask someone, are you left-handed or right-handed, and expect a meaningful answer. People's self-perception doesn't always match their actual behaviour. The most widely used tool is called the Edinburgh Handedness Inventory, developed in the 1970s by a researcher named R.C. Oldfield. It's beautifully simple. It asks people which hand they prefer for 10 specific activities: writing, drawing, throwing, using scissors, using a toothbrush, using a knife without a fork, using a spoon, using a broom, striking a match, and opening a box lid. For each activity, you indicate whether you strongly prefer your left hand, strongly prefer your right hand, or have no preference. The responses get converted into a numerical score that ranges from -100, meaning extremely left-handed, to +100, meaning extremely right-handed. 0 would be perfectly ambidextrous. What this reveals is fascinating. When you plot everyone's scores on a graph, you don't get two separate peaks with most people clustered at the extreme right and a smaller group clustered at the extreme left. Instead, you get a continuous distribution that's heavily skewed toward the right. Most people score between +50 and +100, but there's a long tail extending leftward that includes everyone from slightly mixed dominant people all the way to extreme lefties. That distribution tells us something profound. Handedness isn't determined by a single gene that's either on or off. It's influenced by multiple genetic factors, plus environmental influences, plus probably some random developmental noise during brain formation. It's a complex trait, like height or intelligence, that emerges from the interaction of many different factors. But here's where it gets really weird. Handedness isn't the only asymmetry in your body. It's part of a larger pattern that includes footedness, eyedness, and even earedness. Footedness is which foot you prefer for kicking, stepping up onto something, or balancing. About 80% of people are right-footed, but the correlation with handedness isn't perfect. You can be right-handed but left-footed, or vice versa. Eyedness is which eye you naturally use for sighting when looking through a telescope or aiming a camera. Most people have a dominant eye they don't even know about until they test it. Interestingly, eye dominance is less strongly correlated with handedness than footedness is. Plenty of right-handers are left eye dominant. Earedness is which ear you prefer for listening to a phone call or pressing against a door to hear what's on the other side. This one's the weakest asymmetry. Many people don't have a strong ear preference at all. What ties all these together is brain lateralization, the tendency for different functions to be concentrated in different hemispheres of your brain. In most right-handers, language processing is concentrated in the left hemisphere, which also controls the right side of the body. But in left-handers, it's more complicated. About 70% have language in the left hemisphere, same as righties. About 15% have it in the right hemisphere, and about 15% have language distributed across both hemispheres. This means left-handedness isn't just about which hand you write with. It's a window into how your brain is organized, how the two halves of your mind divide up the work of thinking, perceiving, and controlling your body. And here's the final mystery. That 10% figure, it's stable. Remarkably, almost eerily stable. Across cultures, across continents, across centuries, even across millennia, when we can determine it from archaeological evidence, roughly 10% of humans are left-handed. The exact number varies a bit depending on how you measure and how much cultural pressure exists to conform. In societies where left-handedness is strongly discouraged, the visible rate might drop to 5 or 6%. In more accepting societies, it might rise to 12 or 13%. But it always clusters around that same figure. This stability is the clue. Natural selection has had hundreds of thousands of years to eliminate left-handedness if it wanted to. The fact that it hasn't suggests something important. There's a reason for that 10% to exist, an advantage hidden somewhere in human evolution that makes it worth preserving the minority. We're about to discover what that advantage might be. Now comes the question that should be obvious by now. If left-handedness exists today, has been maintained at roughly 10% for as long as we've been measuring, and natural selection hasn't eliminated it, then it must be old, really old, ancient. But how ancient? The answer is hidden in rocks, bones, and cave walls. And it tells a story that reaches back hundreds of thousands of years. Start with the simplest evidence: stone tools. For millions of years our ancestors made tools by striking one rock against another, flaking off sharp pieces in a controlled way. It sounds simple, but it's not. Try it sometime. You'll end up with crushed fingers and a pile of useless rock fragments. Making a functional stone tool requires precision, planning, and most importantly, a dominant hand. When a right-handed person makes a stone tool, they typically hold the core in their left hand and strike it with their right. This creates a characteristic pattern. The flaking angles go in one direction. The impact points cluster on one side. The whole geometry of the tool reflects the handedness of its maker. Archaeologists have known this for decades, but for a long time they didn't think to analyze it systematically. Why would they? Handedness seemed like a trivial detail compared to the big questions about human evolution. Then in the 1980s, researchers started actually measuring the angles, plotting the flake patterns, comparing tools across sites and time periods, and they found something remarkable. The pattern was consistent. About 90% of stone tools from the past 200,000 years show right-handed manufacturing. About 10% show left-handed patterns, or ambiguous characteristics that could indicate left-handed makers. The ratio holds across continents, across cultures, across time. Whoever was making these tools, wherever and whenever they lived, roughly 90% were right-handed and 10% were not. But the evidence goes deeper than just the tools themselves. It's written in the wear patterns, the microscopic scratches that accumulate on stone implements through use. When you cut meat or scrape hide with a stone tool, the direction you move it, the angle you hold it, the hand you use, all of this leaves traces. Under high-powered microscopes, these traces tell stories. Researchers analyzing 300,000-year-old tools from Africa found consistent right-hand dominant wear patterns. Tools from Neanderthal sites in Europe, some dating back 150,000 years, show the same thing. Even more ancient implements from species that preceded modern humans show evidence of handedness preferences. Right-hand dominance isn't just a human thing, it's a hominin thing. It goes back to the very roots of our family tree. But perhaps the most intimate evidence comes from Neanderthal teeth. This sounds strange, but stay with me. Neanderthals, those robust Ice Age humans who lived across Europe and Western Asia, had a distinctive feeding habit. When they ate meat, they would hold one end in their teeth and cut off pieces with a stone tool held in their hand. We know this because their front teeth show distinctive wear patterns, scratch marks running at angles across the enamel. And here's the crucial detail. The angle of those scratches reveals which hand held the tool. If you're right-handed and you're holding meat in your teeth and cutting it with your right hand, the scratches angle one way. If you're left-handed, they angle the other way. It's like a signature written in tooth enamel, preserved for tens of thousands of years. When researchers analysed Neanderthal teeth from multiple sites across Europe, they found the same 90-10 pattern. Most showed right-handed cutting. A minority showed left-handed patterns. The 10% were there, living among their right-handed cousins, surviving the Ice Age, raising families, leaving their mark in the fossil record. But the evidence that captures the imagination most powerfully doesn't come from tools or teeth. It comes from caves. Deep in limestone caverns across Europe, places like El Castillo in Spain, Chauvet in France, Pech-Merle in the Dordogne, ancient humans left something extraordinary. Hand stencils. Negative images created by placing a hand against the rock wall and blowing pigment around it. They're hauntingly beautiful, these hands reaching out to us across 30,000, 40,000 years. Some are so well preserved you can see the individual fingerprints, and they reveal handedness. When you make a hand stencil, you have a choice. You can place your left hand on the wall and spray pigment with your right, or vice versa. Most people use their dominant hand to do the precise work of spraying, placing their non-dominant hand against the wall. This means most hand stencils show the non-dominant hand. Researchers have catalogued thousands of these stencils from dozens of cave sites. They've measured them, analysed them, counted them, and they found that about 10% appear to be right hands, suggesting the artists were left-handed and placed their dominant hand on the wall while spraying with their left. It's the same ratio we see everywhere else. The same 10% that exists today existed then. These weren't all made by the same people, or even the same culture. Cave art spans thousands of years and multiple human populations. But through all that time, through all those different groups, the ratio remained stable. 10% left-handed, 90% right-handed. Something was maintaining this balance, keeping it constant even as human populations evolved, migrated, and adapted to radically different environments. But not all ancient cultures treated handedness equally, and this is where the evidence becomes darker, more troubling. The ancient Egyptians, with their obsessive attention to artistic detail, had strong conventions about how to depict human figures. In formal art, proper Egyptians were shown in standardized poses, doing things the right way, the proper way, and the proper way was right-handed. Left-handedness in Egyptian art appears only in specific contexts: enemies in battle scenes, foreigners engaged in strange customs, demons and chaos entities. The iconography is subtle but consistent. To depict someone as left-handed was to mark them as other, as outside the proper order of things. It wasn't just artistic convention. It reflected a worldview in which right-handedness represented order, civilization, correctness, while left-handedness represented chaos, foreignness, wrongness. The Greeks and Romans took this further, embedding it in their language itself. The Latin word for left was sinister. Yes, that's sinister. The one that still means threatening, evil, malevolent in modern English. The word for right was dexter, which gives us dexterous, meaning skillful and adroit. The linguistic bias was explicit. Right equals good, skillful, proper. Left equals bad, clumsy, threatening. Greek and Roman authors wrote casually about left-handedness as an unfortunate condition, a minor deformity to be corrected if possible. They associated it with weakness, bad luck, and untrustworthiness. To take an oath with your left hand was to make it invalid or even blasphemous. To offer your left hand in greeting was an insult. The prejudice was systematic and pervasive, and yet, despite all this cultural pressure, despite centuries of stigma and attempts at correction, the 10% persisted. You can see it in the archaeological record of classical antiquity. Tools, weapons, wear patterns on ancient amphitheatres where gladiators trained all show the same ratio. About 10% of Romans were left-handed whether Roman culture approved or not. This becomes especially interesting when you look at military equipment. Ancient armies were sophisticated organizations with standardized gear. Roman legionaries all carried their shields on their left arms and their swords in their right hands. This wasn't just tradition, it was tactical necessity. In a tightly packed formation like the Roman shield wall, everyone needed to be doing the same thing or the formation would fall apart. A left-handed swordsman in a right-handed formation would be a liability, striking his comrades as often as the enemy. So what happened to left-handed soldiers? Were they excluded from military service, forced to fight right-handed? The historical sources are mostly silent on this, but the archaeological evidence suggests something more nuanced. Some shields show wear patterns indicating left-handed use. Some swords were clearly designed for left-handed grips. Not many, but some. Enough to suggest that exceptional left-handed fighters found ways to serve, probably in specialized roles where formation fighting wasn't required. Skirmishers, perhaps. Scouts. Specialists who fought as individuals rather than in the rigid lines. The gladiatorial arenas provide more evidence. Gladiators were valuable property, expensive to train and maintain. If a left-handed fighter showed promise, no rational owner would force him to fight right-handed and reduce his effectiveness. The goal was to win, not to conform to cultural preferences about handedness, and the archaeological remains of gladiatorial schools show equipment designed for left-handers. Specialized arm guards, practice weapons with reversed grips, training areas with markings suggesting left-handed combat drills. This suggests something crucial about left-handedness in the ancient world. Despite the cultural stigma, despite the linguistic bias, despite the religious prejudices, when it actually mattered, when survival or success was on the line, left-handers were recognized and accommodated. Because they were valuable. Because they offered something that right-handers didn't. An advantage. A difference that made them worth keeping around, even in societies that viewed left-handedness with suspicion. But we're getting ahead of ourselves. Before we can understand why left-handedness persisted despite cultural pressure, we need to understand where it comes from in the first place. What makes someone left-handed? Is it genetic, environmental, random chance? The answer turns out to be far more complicated and fascinating than anyone expected. If you're left-handed, there's a decent chance someone else in your family is too. Maybe your mother, maybe an uncle, maybe your grandmother who was forced to write right-handed but still threw balls with her left. The family clustering is obvious enough that for centuries people assumed left-handedness must be inherited, passed down through generations like eye colour or height. But here's where things get weird. Two right-handed parents can have a left-handed child. Happens all the time. In fact, it happens in about 9% of families where both parents are right-handed. Meanwhile, if both your parents are left-handed, you've only got about a 26% chance of being left-handed yourself. That's better odds than the general population, sure, but it's not exactly Mendelian inheritance. If left-handedness were controlled by a simple recessive gene, like blue eyes, two left-handed parents should only produce left-handed children. The math doesn't work. So scientists went looking for the left-handed gene. Surely it had to be there somewhere, hiding in our DNA, waiting to be discovered. They started with family studies, tracking handedness through multiple generations. They found patterns, weak correlations, hints that genetics mattered. Then they moved to twin studies, comparing identical twins who share 100% of their DNA with fraternal twins who only share 50%. If handedness was purely genetic, identical twins should always have the same handedness. Fraternal twins should be no more similar than regular siblings. The results were baffling. Identical twins are more likely to share handedness than fraternal twins, but only slightly. About 76% of identical twin pairs have matching handedness, compared to 72% for fraternals. These are small differences, much smaller than you'd expect if genes were calling all the shots. Even more puzzling, about 24% of identical twin pairs don't match at all. Same DNA, different handedness. How is that even possible? The answer had to be that handedness wasn't controlled by one gene or even a few genes. It had to be more complex, more distributed across the genome. So researchers started doing genome-wide association studies, scanning the entire human genome looking for genetic variants that showed up more often in left-handers than right-handers. They collected data from thousands of people, then tens of thousands, then hundreds of thousands. They had the statistical power to find even tiny genetic effects, and they found them. Sort of. In 2019, a massive study of 400,000 people identified several genetic regions associated with handedness. The effects were real, they were reproducible, but they were also incredibly small. The strongest genetic variant they found only increased your odds of being left-handed by about 1.5%. Combined, all the variants they identified explained less than 1% of the variation in handedness across the population. This is not how genetics is supposed to work when a trait runs in families. But one gene kept showing up in studies, LRRTM1, a gene on chromosome 2 that does something interesting. It helps control the asymmetry of the human brain, specifically which side develops certain language and motor control centers. In most people, language processing is concentrated in the left hemisphere. The left hemisphere also controls the right side of the body, which is why most people are right-handed. LRRTM1 influences this asymmetry. Certain variants of the gene seem to weaken the usual left hemisphere dominance, allowing the right hemisphere to take over motor control more often. People with specific LRRTM1 variants are slightly more likely to be left-handed. They're also slightly more likely to develop schizophrenia, which might sound alarming until you remember that schizophrenia is fundamentally a disorder of brain asymmetry. The same genetic variation that allows for left-handedness might also, in rare cases, allow for more severe disruptions of normal brain organization. This doesn't mean left-handers are at higher risk for schizophrenia. The effects are far too small for that. But it does suggest that handedness and brain organization are deeply connected at the genetic level. Other candidate genes emerged from the research, PCSK6, which helps establish left-right asymmetry in the developing embryo, not just in the brain but throughout the body. Variants of PCSK6 are associated with both left-handedness and with having your internal organs reversed, a rare condition called situs inversus. MAP2, which helps build the structural scaffolding inside brain cells, allowing neurons to grow in organized patterns. Variants affect how the left and right hemispheres connect to each other, and dozens of other genes, each contributing tiny effects, each nudging the probability of left-handedness up or down by fractions of a percent. Add them all up, and you've got maybe 25% of the variation in handedness explained by genetics. That's not nothing, but it's nowhere near enough to explain the family clustering researchers had observed. Something else had to be going on, something that happened after conception, during the long process of development from embryo to infant to child. Enter the Geschwind-Gallerberder hypothesis, proposed in the 1980s by neurologist Norman Geschwind and his colleague Albert Gallerberder. They noticed something interesting. Left-handers seem to have higher rates of certain conditions like autoimmune disorders, learning disabilities and allergies. They also seem to have higher rates of mathematical and musical talent. What could connect these seemingly unrelated traits? Their answer was testosterone. Specifically, exposure to high levels of testosterone in the womb during critical periods of brain development. Testosterone, they argued, slows down the growth of the left hemisphere, which develops slightly later than the right. In most fetuses, the left hemisphere eventually catches up and becomes dominant for language and motor control. But in fetuses exposed to higher testosterone levels, the right hemisphere gets a head start and sometimes maintains its advantage. Result: left-handedness, along with different patterns of brain organization that might explain both the disabilities and the talents. The hypothesis was brilliant, provocative, and almost certainly too simple. But it captured something real. Studies have found weak correlations between testosterone exposure and handedness. Men are slightly more likely to be left-handed than women, about 12% versus 10%, which would fit the testosterone theory. Left-handed individuals do show slightly different patterns of brain asymmetry, with language and spatial processing more distributed across both hemispheres rather than concentrated in one. But the correlations are weak, the effects are inconsistent across studies, and testosterone definitely doesn't explain everything. Plenty of left-handers don't show the patterns Geschwind and Galaburda predicted. Plenty of right-handers do. The hypothesis has been revised, refined, and qualified so many times that it's barely recognizable anymore. But it did something important. It shifted attention from genes alone to the complex process of development, where genes interact with environment to build a brain. Because that's really what's happening. Handedness isn't determined at conception. It emerges gradually during fetal development, infancy, and early childhood. At 15 weeks gestation, fetuses already show hand preferences in the womb, sucking their left or right thumb more often. But these preferences aren't fixed. They can change. Most children don't show consistent handedness until age 3 or 4. Some don't settle into a clear preference until age 6 or 7. During all this time, the brain is organizing itself. Billions of neurons are forming trillions of connections. The two hemispheres are specializing, with certain functions concentrating on one side or the other. This process is guided by genes, yes, but it's also influenced by random developmental variation, by the exact chemical environment in the womb, by early experiences and learning. It's chaotic, probabilistic, sensitive to small perturbations. This is where epigenetics enters the picture. Epigenetics refers to changes in gene expression that don't involve changes to the DNA sequence itself. Chemical tags get attached to your DNA, switching genes on or off in response to environmental conditions. These changes can happen in the womb, during childhood, even in adulthood. They can be influenced by maternal stress, nutrition, hormones, random molecular accidents, and they help explain why identical twins don't always share handedness despite sharing DNA. Think about it this way. You've got two embryos with identical genetic code developing in the same womb at the same time, but they're in slightly different positions. One is getting slightly more blood flow. The other is experiencing slightly different hormone concentrations. These tiny differences get amplified during development. One embryo's brain develops with stronger left hemisphere dominance. The other develops with more balanced hemispheres or even right hemisphere dominance. By the time they're born, they might have different handedness despite having identical genes. Or sometimes biology just rolls the dice. There's evidence that handedness is partly determined by random developmental noise, the kind of quantum-level randomness that affects which proteins fold which way, and which neurons connect to which targets. Genes set up the playing field, hormones and epigenetics influence the rules, but ultimately there's an element of chance. You can't predict it perfectly, even if you knew everything about someone's genes and environment. The system is inherently probabilistic. This explains the frustrating patterns geneticists kept finding. Yes, handedness runs in families, because children share genes and often share prenatal environments with their parents. But the inheritance is weak and inconsistent because genes only create predispositions, not destinies. They load the dice without determining the outcome. A child with two left-handed parents has dice loaded in favor of left-handedness, but the dice still have to be rolled, and developmental processes still have to unfold, and random chance still gets a vote. So after decades of research, hundreds of studies, and data from millions of people, we've arrived at an answer that is deeply unsatisfying if you like simple explanations. Left-handedness is about 25% heritable, influenced by dozens or maybe hundreds of genes with tiny effects, modulated by testosterone and other hormones in the womb, shaped by epigenetic changes and developmental variation, and ultimately determined by a complex interplay of genetics, environment, and pure chance. Which raises an even bigger question. If handedness is this complex, this difficult to pin down genetically, how has it persisted in human populations for hundreds of thousands of years? Why hasn't natural selection eliminated it or fixed it at some stable percentage? The answer lies not in genetics at all, but in something far more interesting: the architecture of the human brain itself. Your brain is not symmetrical. This might seem obvious, but the implications are profound. The 3-pound organ sitting in your skull is divided into 2 hemispheres that look almost identical but function completely differently. And for left-handers, this fundamental architecture works in ways that scientists are still struggling to understand. Let's start with the basics, because nothing about brain organization is actually basic. In roughly 95% of right-handed people, language processing happens primarily in the left hemisphere. Speech production, language comprehension, reading, writing, all controlled by networks of neurons clustered in the left side of the brain. Meanwhile, the right hemisphere handles different tasks: spatial reasoning, face recognition, processing music and emotional tone, understanding context and metaphor. This division of labor is called lateralization, and it's one of the defining features of human brain organization. But here's where it gets interesting. Your left hemisphere controls the right side of your body. Your right hemisphere controls the left side. The neural pathways cross over at the base of the brain, meaning signals from your left motor cortex travel down and across to control your right hand, your right foot, the right side of your face. This crossed wiring system exists in all mammals, but humans have taken it to an extreme. We're the only species that shows such strong hand preference at the population level, and that preference is intimately connected to how our brains organize language and other cognitive functions. For right-handers, the system is straightforward. Left hemisphere for language, left hemisphere controlling the right hand. It's a tidy package. Writing and speaking both controlled by the same side of the brain, reinforcing the dominance of the right hand for precise motor tasks. But left-handers break all the rules. Only about 70% of left-handed people have language processing in the left hemisphere like right-handers do. The remaining 30% show different patterns. Some have language functions in the right hemisphere. Others show bilateral language processing, with both hemispheres sharing the work. A few even have mixed patterns, with different aspects of language scattered across both hemispheres in configurations that seem almost random. This variability is unprecedented. Right-handers show remarkably consistent brain organization. Nearly all of them process language the same way, in the same locations, using the same neural networks. But left-handers, they're all over the map. It's like evolution tried multiple different brain architectures and couldn't decide which one worked best, so it just kept all of them. Brain imaging studies using fMRI technology have revealed just how different left-handed brains can be. When researchers put left-handers in scanners and ask them to perform language tasks, the patterns of activation are far more variable than in right-handers. Some show strong left hemisphere activation, identical to right-handers. Others light up on the right side. Many show significant bilateral activation, with both hemispheres working together in ways that right-handed brains simply don't. This doesn't mean left-handers are worse at language. They perform just as well on verbal tests. But they're achieving the same results through different neural pathways, using different organizational strategies. It's like discovering that 10% of people have learned to solve math problems using a completely different system of arithmetic that somehow arrives at the same answers. The plot thickens when you look at the corpus callosum, the massive bundle of nerve fibers connecting the two hemispheres. This structure is one of the most important in the brain, allowing the left and right sides to communicate and coordinate. Some studies suggest that left-handers have larger or more robust corpus callosums, with more neural connections between the hemispheres. The theory goes like this. If your brain is processing language bilaterally, or if different cognitive functions are distributed differently across the hemispheres, you need better communication between the two sides. Natural selection might have favoured left-handers with stronger interhemispheric connections, individuals whose brain architecture allowed the two sides to work together more efficiently. But the research here is maddeningly inconsistent. Some studies find significant differences in corpus callosum size or connectivity between left and right-handers. Others find nothing. Part of the problem is sample size. Left-handers are only 10% of the population, and brain imaging studies are expensive and time-consuming. Getting enough left-handed participants to draw solid conclusions has proven difficult. What we do know is that left-handed brains show greater variability in almost every measure researchers have examined. Not just language, but spatial processing, memory systems, emotional regulation. It's as if the same genetic and developmental factors that influence handedness also affect overall brain organization in subtle but pervasive ways. This leads to one of the most persistent myths about left-handers, the creativity myth. Popular culture has long claimed that left-handers are more creative, more artistic, more likely to think outside the box. Lists of famous left-handed artists, musicians and inventors circulate constantly, offered as evidence of left-handed creative superiority. The reality is more nuanced. Yes, left-handers do show up in creative professions at rates slightly higher than 10%. Some studies suggest they're overrepresented among architects, artists, and musicians. But the effect is modest, and the reasons aren't clear. Here's what the science actually shows. Left-handers do appear to have advantages in certain specific cognitive tasks. They perform better, on average, at divergent thinking tests, exercises that require generating multiple solutions to open-ended problems. They show slight advantages in spatial reasoning tasks that require mental rotation or visualization. Some studies suggest they're better at making novel associations between unrelated concepts, but these are statistical effects, and they're small. Plenty of right-handers are wildly creative. Plenty of left-handers are conventional thinkers. The overlap between the two groups is enormous, far larger than the differences. What might be happening is that left-handers' more variable brain organization gives them more cognitive flexibility in certain situations. If your brain doesn't process information through the standard pathways, you might be more likely to find unconventional solutions. If your hemispheres are communicating more extensively, you might be better at integrating different types of information. Think of it this way. Right-handed brains are like well-organized filing systems. Everything has its place, information flows through established channels, efficiency is optimized. Left-handed brains are more like controlled chaos. Information might reach the same destinations through different routes, and that flexibility might occasionally offer advantages when facing novel problems. But here's what's really fascinating. The left-handed brain's apparent flexibility might be a feature, not a bug. Throughout human evolution, populations have faced constantly changing environments and challenges. Having a minority of individuals whose brains process information differently might provide adaptive advantages at the population level. When standard solutions fail, when conventional approaches don't work, those individuals with different cognitive architectures might find answers that elude the majority. Modern research using advanced brain imaging techniques is revealing even more complexity. Studies using diffusion tensor imaging, which can trace the actual pathways of neural connections, show that left-handers have different white matter organization. The bundles of axons carrying signals between different brain regions follow different routes, connect different areas, create different networks. This is deeper than just which hemisphere handles which function. This is about the fundamental wiring diagram of the brain being drawn differently, and somehow, despite these significant organizational differences, left-handed brains work just as well as right-handed ones. They process information, generate thoughts, control behavior, create memories, all using a neural architecture that's measurably different from the majority pattern. There's also evidence that left-handed brains show greater neuroplasticity, the ability to rewire themselves in response to injury or changing demands. When right-handers suffer strokes that damage their left hemisphere, they often experience permanent language deficits. Their brains have difficulty recruiting the right hemisphere to take over language functions, but left-handers, especially those who already had some bilateral language processing, often show better recovery. Their brains seem more capable of shifting functions between hemispheres when necessary. This makes evolutionary sense. If left-handedness comes with more variable brain organization and stronger interhemispheric connections, then left-handed brains might be naturally better at reorganizing themselves. And in the harsh environments where human evolution occurred, where traumatic brain injuries from accidents, violence, and disease were common, having a subset of the population with more resilient brain architecture could provide significant advantages. Recent studies have even found differences in how left and right-handers process emotional information. Some research suggests left-handers show different patterns of emotional lateralization, with less clear separation between how the two hemispheres handle positive versus negative emotions. Whether this translates to any real-world differences in emotional experience remains unclear, but it's another piece of evidence that left-handedness is associated with fundamental differences in brain function. The more scientists investigate left-handed brains, the more complexity they uncover. What started as a simple question about why some people prefer their left hand has revealed that a significant minority of humans are literally wired differently. Their brains organize information through different pathways, process language through different systems, connect their hemispheres through different networks, and somehow, despite 200,000 years of evolution, despite countless opportunities for natural selection to eliminate this variation and standardize brain organization, left-handedness persists. These different brain architectures, with all their variability and complexity, have survived because they offer something valuable enough that evolution has actively maintained them in our species. The left-handed brain isn't just different. It's a window into the incredible flexibility of human neurobiology, proof that there's more than one way to build a thinking mind. But understanding why evolution maintained this diversity requires looking beyond neuroscience into the harsh realities of survival in ancestral environments. For tens of thousands of years, left-handers survived because they had value. They were the unpredictable fighters, the unexpected strikers, the ones who could exploit the blind spots in an opponent's defense. Natural selection had kept them around at a stable 10% for good reason. But then something changed. Human societies started organizing themselves around more than just survival. They developed religions, moral codes, systems of proper behavior, and somewhere along the way they decided that left-handedness was wrong. Not wrong as in disadvantageous, wrong as in evil. The seeds were planted early. Ancient languages themselves reveal the bias. The Latin word for left is sinister, which also means threatening, evil, unlucky. The French word gauche means both left and clumsy, awkward, socially inept. In English, we say someone has 2 left feet when they're uncoordinated. The word right means both the direction and correctness, morality, justice. These weren't accidental choices. They reflected a deep cultural association between left-handedness and wrongness that would shape human societies for millennia. But it was the medieval Christian Church that turned prejudice into persecution. During the Middle Ages, church theologians developed an elaborate symbolic system, where right represented God, righteousness, and salvation, while left represented Satan, sin, and damnation. This wasn't metaphorical, they believed it literally. In medieval artwork, God's chosen souls ascend to heaven on his right side, while the damned are dragged to hell on his left. Angels stand to the right of Christ, demons to the left. When priests blessed congregations, they always used their right hand. Using the left would have been blasphemous, an invitation for demonic forces. Left-handed people became suspects by nature. During the witch trials that swept through Europe from the 15th to 18th centuries, left-handedness was sometimes cited as evidence of demonic possession or witchcraft. Accusers pointed to the way suspected witches used their left hands for daily tasks as proof they had made pacts with Satan. It wasn't definitive evidence, but it was noted, recorded, added to the list of suspicious behaviours that could send someone to the stake or the gallows. The psychological impact was devastating. Imagine being a left-handed child in the 16th century Europe. From your earliest years, every time you reach for something with your natural hand, adults would react with horror. Your parents would slap your hand away, force you to use the right one instead. Teachers would tie your left hand behind your back or to your chair. Priests would warn you that your natural inclination was the devil's mark upon your soul. You learned to hate a fundamental part of yourself, to see your own body as corrupted and wrong. But the persecution wasn't limited to Christian Europe. Cultures around the world developed similar taboos, often independently. In many Islamic societies, the left hand became designated as unclean, reserved exclusively for bathroom hygiene. Using your left hand to eat, to greet someone, to handle the Quran, these were serious offences against social and religious propriety. Left-handed children were forced to switch, not out of cruelty necessarily, but out of genuine concern that they would be unable to function in a society where left-handedness was fundamentally incompatible with basic social interactions. In parts of Africa, Asia, and South America, similar taboos emerged. The left hand was for dirty work, the right for clean tasks and social engagement. Some societies believed left-handedness indicated the child had been cursed in the womb or that the mother had done something wrong during pregnancy. In certain communities, a left-handed child was seen as bringing bad luck to the entire family. The Victorians turned forced conversion into a systematic project. In the 19th century, as industrialization transformed society, left-handedness became redefined as a defect to be corrected through modern scientific methods. Victorian educators and physicians believed they could improve humanity through proper training and moral discipline. Left-handedness was seen as a sign of atavism, a reversion to a more primitive state that could be fixed with enough rigor and determination. Schools implemented strict policies. Teachers would walk the aisles during writing lessons, ruler in hand, ready to strike any child caught using their left hand. The punishment wasn't occasional, it was constant. Every day, multiple times per day, left-handed children faced physical pain for trying to write naturally. Some schools used more elaborate methods. They tied children's left hands to their desks or behind their backs for hours at a time. They forced children to sit on their left hands during lessons. They created special restraining devices that prevented the left hand from moving toward the writing surface. The rationale went beyond simple conformity. Victorian educators genuinely believed that forcing children to use their right hands would improve their moral character, strengthen their willpower, and train them to resist their base instincts. Left-handedness was lumped together with other behaviors that needed to be controlled through discipline, like bedwetting or nail-biting. It was seen as a childish tendency that proper education would eliminate. The psychological toll was immense. Studies conducted throughout the 20th century documented the damage caused by forced conversion. children who were forced to switch hands showed dramatically higher rates of stuttering and other speech impediments. The connection makes sense neurologically. Speech centers in the brain are closely linked to hand preference. Forcing someone to write with their non-dominant hand disrupts these neural pathways, sometimes causing permanent changes to speech patterns. Reading difficulties were common too. Children forced to switch hands often developed dyslexia-like symptoms, reversing letters or reading words backward. Their school performance suffered across the board. Many were labelled as slow learners or mentally deficient, when in reality they were fighting against their own neurology every time they tried to complete an assignment. The emotional damage was perhaps worst of all. Decades later, adults who had been forced to switch hands as children reported lingering anxiety, low self-esteem, and feelings of fundamental wrongness about themselves. The constant punishment for using their natural hand had taught them that something essential about who they were was bad and needed to be suppressed. Some reported nightmares well into adulthood about teachers and rulers and the pain in their left hands. But they also developed coping strategies. Many forced switchers became effectively ambidextrous, using their right hand for writing but their left for everything else. Some learned to switch back and forth depending on whether authority figures were watching. Others developed elaborate methods to hide their left-handedness, positioning their bodies to obscure which hand they were using, practicing right-handed movements until they looked natural. The stories are countless. There's King George VI of England, who was forced as a child to write with his right hand despite being naturally left-handed. Many historians believe this forced switching contributed to his severe stutter, the speech impediment that would define much of his life and become the subject of films and books decades later. His father, King George V, had insisted on the change, believing that a British monarch could not be left-handed. There's Jimi Hendrix's father, who repeatedly tried to force young Jimi to play guitar right-handed, seeing left-handedness as wrong and shameful. Jimi would play right-handed when his father was around, then switch back to left-handed as soon as he left. Eventually, his extraordinary talent made the argument for him, but the early years were marked by conflict and punishment over something as simple as which hand felt more natural. There are thousands of less famous stories. The factory worker who learned to write right-handed in school, but injured himself repeatedly at work because he instinctively reached for tools with his suppressed dominant hand. The artist who painted with a right hand for decades, producing competent but uninspired work, until a stroke paralyzed that hand and forced her to use her left, suddenly unleashing creativity she'd never known she possessed. The teacher who spent his entire career forcing children to switch hands, only to realize in retirement that he'd been perpetuating the same trauma that had been inflicted on him as a child. The shift came gradually through the 20th century. In the 1930s and 40s, psychologists began publishing research on the damage caused by forced conversion. They documented the stuttering, the learning difficulties, the emotional problems. They argued that handedness was neurologically determined, not a behavior that could or should be changed. Educational authorities were slow to respond. Many schools continued enforcing right-handedness well into the 1960s and 70s. But gradually the policies relaxed. Teachers stopped hitting children for using their left hands. Schools began providing left-handed scissors and desks. The cultural attitude shifted from seeing left-handedness as a defect to seeing it as a harmless variation. By the 1980s and 90s, forced conversion had largely ended in developed countries, though it continued in many traditional societies where cultural and religious taboos remained strong. Even today, in parts of the world, left-handed children face pressure to switch, though usually through social expectations rather than physical punishment. The question is why? Why did so many human societies, independently and across different time periods, develop such intense prejudice against left-handedness? The evolutionary explanation suggests it's related to the frequency-dependent selection that maintained left-handers at 10%. They were useful in combat because they were rare. But in peaceful social interactions, rarity became suspicious. Humans are deeply pattern-seeking creatures. We feel uncomfortable with variation from the norm, especially when we can't immediately understand its purpose. But there's another factor. The left-handers who survived did so partly because they were willing to be different, to exploit their uniqueness rather than hide it. They represented a kind of threat to social conformity, a reminder that not everyone fits the same template. In societies built on rigid hierarchies and strict behavioral codes, that kind of variation was dangerous. Not because left-handers themselves posed any real threat, but because they represented the possibility of difference itself. The persecution of left-handers was really about control, about a society's need to make everyone fit the same mold, to eliminate variation, to ensure predictability and conformity. It was about fear of the different and the human tendency to equate different with wrong. But here's what's remarkable. Despite centuries of persecution, despite systematic efforts to eliminate left-handedness from human populations, the percentage never changed. Still 10%, generation after generation. The pressure that maintained that frequency was stronger than any cultural force humans could create. The left-handers survived not just because they were lucky, but because evolution had decided they were necessary. Human prejudice was no match for natural selection's logic. Picture a different kind of bottleneck. Not a climate disaster this time, but a narrow canyon at dawn. The air is cold. Your breath hangs in front of you. You've walked all night with your small warband, feet blistered, hands tight around a spear whose wood is polished where countless fingers have gripped it before you. Ahead, another group is waiting, not strangers, rivals you've raided, been raided by, watched from a distance across river valleys and dry plains. You know how they move, you know how they fight. Your father fought men just like them. So did his father, but they don't know how you fight, because you're left-handed. In our peaceful, electrified late-night world, handedness mostly shows up when you smudge ink, bump elbows at dinner, or wrestle with a can opener clearly designed by a right-hander. In the world your ancestors knew, handedness could mean something much more serious. It could mean who walked away from a fight. Biologists have a term for this, frequency-dependent selection. It sounds abstract, mathematical, like something scribbled on a whiteboard in a university office. But at its core, it's simple. The rarer you are, the more dangerous you become. Imagine every fighter in your community grows up sparring, wrestling, practicing with sticks or spears or bare hands. Day after day, they train to read the body of a right-handed opponent, the way the right shoulder drops just before a strike, the rhythm of footwork when the power hand is in the same place, every time, the angles of attack, the blind spots. Their entire nervous system is tuned to that pattern. Then, one evening, under flickering firelight, they face you, and everything is reversed. Your power hand is where their brain doesn't expect it to be. Your lead leg steps when theirs would normally retreat. The blow they think is coming from their right flashes out from their left. All those precise, well-rehearsed defensive moves suddenly don't quite fit. They're a half-second late, a few centimeters off. In a friendly match, that's just confusing. In a real fight, that half-second can be the distance between a shallow cut and a killing blow. This is the heart of the fighting advantage theory for left-handers. Not that left-handers are stronger or braver or inherently better fighters, but that, in a world dominated by right-handers, their rarity itself becomes a weapon. And the data, as far as it goes, seems to agree. When researchers look at modern combat sports, a curious pattern appears. In most human populations, about 10% of people are left-handed, sometimes a little more, sometimes a little less. But in professional boxing, that number jumps. In some studies, around 20, even 25% of top-level fighters are left-handed or fight in a left-handed stance. Fencing shows something similar. This sport is practically designed to showcase handedness. One opponent, one weapon, narrow angles, fast reactions. In international competitions, left-handers are consistently overrepresented. In some elite tournaments, more than a third of the finalists are left-handed, far above what you'd expect by chance. You see echoes of this in judo, in mixed martial arts, in certain racket sports like table tennis. Even in tennis, where equipment, coaching and strategy can be adjusted, left-handed players punch above their numerical weight. Famous champions like Rafael Nadal turned their left-handed play into a unique tactical problem opponents had to solve. It's not that every left-handed boxer or fencer becomes a champion. Most don't. Skill, training, conditioning and strategy still matter far more. But when you average across thousands of matches and hundreds of athletes, the same signal keeps appearing. In one-on-one physical contests, where reaction, surprise and split-second misjudgments decide outcomes, left-handers seem to enjoy a small but real advantage. Now, in a modern boxing ring, that might mean a slightly better win percentage, a little more prize money, a few more trophies. In a prehistoric raid, when weapons were stone and bone and fire-hardened wood, and you didn't have paramedics waiting just outside the circle, that same small advantage might have meant more children surviving to adulthood, more genes carried forward. Which is where evolution begins to take notice. If left-handers do better in violent face-to-face conflict because they're rare, then natural selection will tend to favour left-handedness in exactly those environments where such fighting is common. But there's a catch. If too many people become left-handed, the surprise disappears. Fighters start training for both stances. The advantage fades. This is the balance hypothesis of handedness. Left-handers may have an edge in certain situations, but that edge only exists while they're in the minority. If they ever became too common, the advantage would collapse, and natural selection would push their numbers back down. The result is a tug-of-war between risk and reward. On one side, there's the increased cost that sometimes comes with being different neurologically, slightly higher rates of some developmental issues, for instance, or the challenges of living in a right-handed world. On the other side, in the right kind of environment, one where fights are frequent, deadly, and often decided in close quarters, there's a powerful payoff for being the unexpected fighter. If those two forces balance out, you get a stable minority. Not 50% left-handed, not zero, but somewhere in the middle, around the level we actually see in modern populations. And humans, for most of our history, lived in exactly the kind of world where a small edge in combat might have mattered a great deal. Blood feuds, raids at dawn, ambushes along game trails, duels over stolen animals or insults or scarce water. Archaeological sites from the Stone Age show skeletons with healed fractures, embedded spear points, skulls cracked by clubs. Ancient cemeteries tell stories of groups wiped out violently, not just by famine or disease, but by other humans. In many small-scale traditional societies studied by anthropologists in the last few centuries, rates of interpersonal violence are much higher than in most modern states. Homicide rates in some of these communities have been estimated at 10, 20, even 50 times contemporary Western levels. And there's another pattern that quietly emerges. In several of these more violent societies, the percentage of left-handers appears to be higher than the global average. For example, some studies of traditional groups in parts of South America and the Pacific have reported left-handedness rates of 15, 20, occasionally even 25%, far above the typical 10. These are communities where hand-to-hand combat, raids, and ritualized fighting were once central parts of life, where boys grew up knowing that one day they might have to stand in a clearing, heart hammering, and face another man with spear or club or bow. The sample sizes are small. The methods are imperfect. These are not clean, laboratory-controlled experiments. But as a pattern, it's suggestive. Where violence is more common, left-handedness sometimes becomes more common too, as if natural selection is quietly tuning the population, rewarding the rare fighters who can use their unusual orientation as a weapon. This idea isn't new. Thousands of years ago, storytellers had already noticed something about left-handed warriors. In the Hebrew Bible, there's a curious little detail in the book of Judges. It describes a group of soldiers from the tribe of Benjamin. 700 men who were, the text emphasizes, all left-handed. Each one, it says, could sling a stone at a hare and not miss. This isn't just a throwaway line. It's repeated, highlighted. To the ancient writer, the left-handedness of these warriors was worth recording. So was their deadly precision. Elsewhere in the same book, the hero Ehud is described as left-handed. He uses this to his advantage. When he visits a foreign king, the guards check where they expect a right-handed man to hide a weapon, and find nothing. Ehud has strapped his blade to the opposite thigh. When the moment comes, his left hand draws from an unexpected angle. The king doesn't have time to react. Now, did these stories preserve a real military practice, a specialized corps of left-handed slingers, or are they symbolic, emphasizing the tribe's uniqueness? It's hard to know. But the fact that left-handedness is mentioned at all suggests ancient observers had already linked it with something unusual in combat. And it wasn't just the warriors themselves who thought carefully about handedness. The very architecture of medieval warfare seems to carry its imprint. Walk up the spiral staircase of a stone castle, if you ever get the chance. Notice the direction of the turn. In many European fortifications, the stairs twist clockwise as they rise. It's not an accident. It's a design choice with blood in it. Picture an attacker storming the tower, sword or spear in his right hand. As he climbs the narrow clockwise staircase, the inner wall on his right side cramps his weapon. There's barely any room to swing. The outer side on his left is open, but he has no blade there. Now imagine the defender coming down the stairs, also right-handed. His sword arm is on the outside edge of the spiral, with all the open space he needs to strike downward. Gravity is on his side. The architecture itself has become a weapon favouring the defender's dominant hand. But what about a left-handed attacker? He's in the minority, so the staircase wasn't designed with him in mind. Yet on that cramped spiral, his blade now occupies the open side. His left arm has space to strike where a right-hander would be jammed against the inner wall. In a small, twisting, chaotic melee, that could be a genuine advantage. Did castle architects explicitly think, but what about left-handed enemies? Probably not, or at least there's no solid documentary evidence that they did. The main goal was to disadvantage the typical attacker, and the typical attacker was overwhelmingly right-handed. Left-handers were too rare to dictate building codes. But the geometry of stone still created a loophole. In a world built for right-handers, a left-handed fighter could sometimes find unexpected angles, unexpected openings, even in staircases designed to kill him. This is the strange position left-handers have often occupied in human history. Not the default, not the assumed, but occasionally in very specific circumstances the best possible fit. In a world where violence was a daily possibility, these accidental advantages mattered. A right-hander could train to fight another right-hander thousands of times. A left-hander, if he survived his first few encounters, might find that most opponents simply weren't ready for him. But evolution is patient. It doesn't push all the way to extremes. If the fighting advantage of left-handedness is real, and the evidence points that way, even if it's not yet ironclad, it comes with built-in breaks. Make left-handers too common, and opponents adapt. Training systems shift. Young warriors practice with both stances. Whatever surprise the minority once held dissolves. At that point, any downsides of left-handedness, whether biological or cultural, start to matter more again, and the frequency is nudged back down. So the system settles into a rough equilibrium, a small, persistent minority, big enough that the trait never disappears, small enough that it never loses its edge entirely. Across tens of thousands of years, through spears and swords and boxing gloves, left-handers have occupied that narrow slot, not so rare as to vanish, not so common as to become ordinary. Their hands write awkwardly on school desks designed for others. They bump elbows at shared tables. They curse scissors and can openers. But in the shadows of history, in the ring, in the duel, on the spiral stair, their difference may sometimes have been exactly what kept them, and their descendants, alive. And that quiet, dangerous advantage in the oldest human game of all, the game of conflict and survival, may be one of the reasons left-handedness still walks beside us today, an enduring minority in a right-handed world. Now shift the camera in your mind forward in time. Human evolution has done its brutal work. The bottlenecks, the ice ages, the migrations, all of that is behind us. Cities exist now, cathedrals, empires, concert halls, universities. The tools are no longer stone flakes and fire-hardened spears, but quill pens, paintbrushes, violins, telescopes, and primitive computers filling entire rooms. And through all of this, that stubborn 10% of left-handers kept appearing in every generation, like a quiet watermark running through human history. You can trace them if you know where to look, in the slant of brush strokes across a ceiling, in the direction of a musician's guitar, in the cramped sideways angle of handwriting on brittle paper, in the stories that survive about how they held a sword, or a pen, or the hand of a nation. Begin with the man whose notebooks still feel like an alien mind fell to earth. Leonardo da Vinci. Imagine him at a wooden table in some dim Florentine workshop, oil lamp flickering, the air smelling of smoke and varnish. Sheets of paper spread out in front of him. Anatomical sketches, flying machines, gears and pulleys, studies of light and water. He dips his quill in ink and starts to write. But if you or I lean over a shoulder, the words look wrong. The letters are reversed, as if someone has flipped reality in a mirror. To read them easily, you literally have to hold the page up to a looking glass. This is Leonardo's famous mirror writing. People have offered explanations for centuries. Was he hiding his ideas so others couldn't steal them? Was he protecting himself from church authorities, who might not appreciate drawings of dissected corpses and speculative flying machines? Was it just a quirky code, a private game? Those are possibilities. But there's another idea that fits neatly with that 10%. He was very strongly left-handed. Writing in ink with a quill as a left-hander creates a simple, annoying problem. You smear everything. Your hand moves across the fresh letters, dragging the still wet ink into a blur. Unless you do something clever, reverse the direction, and suddenly being left-handed becomes an advantage. Your hand trails behind the writing, not over it. The ink stays crisp, the page stays clean. Mirror writing is no longer a mysterious cipher. It's a practical adaptation in a right-handed world. And it may also tell us something about how Leonardo's brain worked. Left-handers, on average, show slightly different patterns of brain lateralization. The lines dividing language, spatial reasoning, and visual processing between hemispheres can be less rigid, more flexible. Leonardo wasn't just a painter or an engineer or an anatomist. He was all of those at once. His notebooks fuse art and science without even acknowledging a border between them. When you look at those backwards pages, you're not just seeing a trick of the hand. You're seeing a mind comfortable thinking in reversals, reflections, rotations. A brain that could imagine a human heart not just as a symbol of emotion, but as a pump with valves and vortices, then flip that mental image around and draw it from every angle. The left hand is just the visible clue. Now look up. You're standing in the Sistine Chapel. The room is quiet late at night, after the crowds have gone home. The ceiling floats above you like a stone sky. Adam reaching out to the hand of God. Prophets, sibyls, curling bodies, the entire story of creation stretched overhead. For centuries, people assumed Michelangelo painted all this the way most artists did. Right hand, brush up to the plaster. Then X-rays, close studies, and careful analysis of the brushwork started to suggest something stranger. The strokes, the direction of the shading, the way the paint is laid down, all hint that Michelangelo may have worked predominantly with his left hand, especially on the ceiling. Picture him there, lying on scaffolding, body twisted, arm raised for hours, days, years, his hand cramping, pigment dripping into his eyes. In those extreme physical conditions, you don't choose which hand to use based on social expectation. You use the hand that feels natural, the one that gives you control. Documents from his time mention a left-handed tendency. Sketches show hatching and shading consistent with a left-hander's movement. It isn't absolute proof, but the pattern keeps pointing in the same direction. If this is true, then two of the greatest artists of the Renaissance, Leonardo designing fantasies of the future, Michelangelo carving and painting human bodies that look like they could breathe, were both working from that same 10% variant. In an era when left-handedness was often discouraged, punished, or literally tied behind a child's back, they turned it into beauty that still pulls necks upwards centuries later. But not every left-handed figure in history is remembered for what they created. Some are remembered for the empires they commanded. Napoleon Bonaparte is one of them. Open almost any list of famous left-handers, and his name appears near the top. The mighty general, the emperor of the French, the man whose campaigns reshaped Europe, and whose face still stares out from portraits with that famous hand tucked into his waistcoat. But here the story gets slippery. Was Napoleon actually left-handed? The evidence is mixed. Some contemporaries described him writing with his right hand. Military documents and signatures are consistent with right-handed penmanship. Portraits often show him holding a sword or telescope in the right hand. So how did he become a legendary left-hander? Part of it may be simple myth-making. In the 19th and 20th centuries, authors and illustrators liked the idea that great generals were different, that they saw the battlefield from an unexpected angle, attacked from the side others didn't anticipate. Left-handedness, with its built-in asymmetry, became an easy metaphor for strategic unpredictability. It's possible Napoleon had some degree of mixed-handedness, or that he favoured his left in certain tasks. But when historians look closely, the case for him as a clear, consistent left-hander weakens, and yet the myth persists. That persistence is telling. It shows how strongly we've come to associate left-handedness with a certain kind of mind, unconventional, strategic, a little bit dangerous. Whether or not Napoleon truly fit the category, people wanted him there. They wanted the man who rewrote Europe's map to have literally led with the opposite hand. If Napoleon is a doubtful member of the left-handed club, others in power are not. Move now to the polished corridors of European palaces. Soft candlelight reflecting on gold-framed portraits, scrolls, wax seals, and ceremonial pens. Queen Victoria, ruler of the British Empire at its height in the 19th century, appears in this story too. Surviving records and handwriting analysis suggest she favoured her left hand. Observers described awkward attempts, especially in childhood, to make her write with her right. A familiar story, a natural left-hander pushed toward conformity, then slipping back toward what felt normal whenever possible. She wasn't alone among royals. Throughout European history, hints of left-handed monarchs and princes keep surfacing. Unusual sword grips in paintings, reversed signatures, descriptions by tutors and courtiers. Not all are certain, but the pattern is suggestive. In a world obsessed with lineage, bloodlines, and inherited traits, left-handedness would quietly run through dynasties the same way eye colour and jawlines did. A queen signing documents with a left hand, a prince fencing with a stance that wrong-footed his opponent. Small deviations in a rigid ceremonial world then cross the ocean. The setting shifts to a younger nation, to crowded campaign rallies, crackling radio addresses, grainy black and white footage, and later, high-definition debates broadcast to millions. American presidents. If you take all US presidents, the percentage of left-handers looks roughly similar to the general population. But something changes when you zoom in on the 20th century. Suddenly the 10% starts to look more like a pattern. Harry Truman is sometimes listed as ambidextrous, with a strong left-hand preference. Gerald Ford, a star athlete before politics, was left-handed. Ronald Reagan is reported as naturally left-handed, retrained early in life, a common practice in his generation. George H.W. Bush wrote left-handed. Bill Clinton, distinctly left-handed. Barack Obama, famously signing bills and documents with a left hand that cameras love to capture. Not every recent president has been left-handed, of course, but the cluster is notable. Is there a deep explanation? Maybe, maybe not. It could be partly statistical noise. It could reflect shifting attitudes. As the social stigma against left-handedness eased in the 20th century, fewer children were forced to switch, so more left-handers reached visible positions without hiding it. There's also the possibility that the same slight neural differences that show up in many left-handers, more bilateral language representation, different patterns of connectivity, might correlate with certain strengths in communication, improvisation, or problem-solving under pressure. Skills that help in modern politics, we can't say for sure. But the visual of modern presidents, pens poised in their left hands as they sign laws and treaties, has become part of the public memory. The minority hand guiding majority power. Now leave the halls of power and step onto a stage. The lights go down, the crowd hums, an amplifier crackles to life. A single guitar hangs low against a musician's body, strap cutting across a left shoulder, neck angled the wrong way. For right-handed audiences, it looks slightly off at first glance. Then the sound hits, and nobody cares which hand is doing what. Left-handed musicians have always had to deal with instruments built for the other 90%. Violins, pianos, drum kits, guitars. Almost every design assumes the dominant right hand will handle the finest motions. Most left-handed musicians adapt. They learn right-handed instruments, retraining their brains and fingers. But some decide to flip the world around them instead. Picture Jimi Hendrix on stage, a left-hander playing a right-handed guitar turned upside down, strings reversed. The instrument is literally reversed in his hands, the bass strings where the treble strings usually are, the controls and whammy bar on the opposite side. This oddness becomes part of his sound. Bends, vibrato, chord voicings, the way notes ring and sustain, all slightly different because the geometry of his playing is different. His left-handedness isn't just a biographical detail, it's woven into the texture of his music. Then there's Paul McCartney, a left-handed bassist and guitarist in the Beatles, one of the most influential bands in history. Watch old performance footage and you'll see it instantly. The mirror image stance, his bass neck pointing the opposite way of his bandmates' guitars. Songwriting, melody, bass lines that dance and underpin the music at once, all shaped, physically, by a left hand leading. Later in the 1990s, Kurt Cobain of Nirvana walks on stage with left-handed guitars in an era when such instruments are more available but still less common. His playing, aggressive and raw, helped define an entire genre. Again, that reverse stance, that left-hand dominance, becomes part of the visual language of rebellion. In each case, being left-handed forced an early choice: conform to right-handed instruments, or bend the tool to fit the body. Either way, extra adaptation was required, extra thought, extra work, and that extra work might have opened small, unexpected doors in style and technique. Step quietly now into a different kind of stage, a laboratory, a chalkboard, a dimly lit room with notes full of equations, diagrams, logical symbols. Not all left-handers are artists or leaders. Some are the people who pry open the invisible rules of the universe. Marie Curie is often cited as left-handed, though the evidence is not fully conclusive. Surviving photographs suggest a preference, and some accounts support it, but records from her time were not always precise about such details. Still, imagine her in that makeshift lab in Paris, stirring glowing radioactive samples with painstaking care, handwriting crammed notes late into the night. She discovered 2 new elements, pioneered research into radioactivity, and became the first person in history to win Nobel Prizes in 2 different scientific fields. If she was indeed left-handed, she joins a group of scientists and innovators who seemed comfortable working at the edges of the known world. One member of that group is much more clearly documented: Alan Turing, mathematician, codebreaker, and one of the intellectual fathers of computer science. Turing was left-handed. In photographs you can see the pen in his left hand, the chalk held awkwardly but confidently as he writes on a board. During World War II at Bletchley Park, Turing and his colleagues worked to crack the German Enigma codes. It was an exercise in pattern recognition, logic, and imagination, seeing possibilities where others saw only noise. Later, in his theoretical work, he essentially outlined the blueprint for the modern computer before such machines properly existed. It's tempting to draw a neat line. Left-handedness leads to unconventional thinking, which leads to genius, but reality is rarely that simple. Most geniuses are right-handed, just as most people are. Left-handers are a minority in every field. Yet when researchers look at certain populations, especially among people working at the extreme ends of creativity, mathematics, or spatial reasoning, a slight overrepresentation of left-handers sometimes appears. Not a dramatic one, not a guarantee, but a hint. It may be that the same developmental processes that occasionally produce left-handedness also, in some individuals, produce brains that are wired in less typical ways. Brains more likely to combine ideas across domains, to flip perspectives, to approach problems from the metaphorical left when everyone else is coming from the right. Or it may be simpler. Being left-handed in a right-handed world forces constant small adaptations. Every desk, every tool, every door handle is a tiny puzzle. Over years, thousands of these micro-challenges might exercise parts of the brain that handle flexibility, inhibition, and problem-solving. The world, from a left-hander's point of view, is slightly but persistently misaligned. Learning to live in it means learning to think around edges. What we can say, without exaggeration, is this: from vaulted ceilings to battlefields, from thrones to voting booths, from concert stages to code-breaking huts, left-handers have always been there. Not as a separate species or a secret society, but as a quiet, consistent thread running through our shared story. The 10% that natural selection never pruned away did more than just survive. They painted the sky, they signed laws, they bent guitars to their will, they cracked codes, split atoms, and imagined machines that could think. And all the while, most of them were just living their lives in a world built for the opposite hand, adapting day by day in ways no one bothered to record. To see them clearly, you have to look closely. Watch which hand holds the pen, which arm lifts the sword, which fingers dance on the strings. Then you start to notice that in every era, in every culture, that minority keeps resurfacing. The question is why? Why did evolution keep them? What was the advantage that balanced out the inconvenience? To answer that, you have to leave the painters and presidents behind and walk back into the realm of everyday life, into classrooms and factories, kitchens and offices, into all the small, invisible negotiations that left-handers make every day just to exist in a right-handed world. Because hidden in those daily struggles is the evolutionary riddle's final clue. Picture yourself waking up tomorrow in a world where almost every object in your home, every tool at your job, every line on every page was designed for a body that isn't quite yours. Not a different species, not a different size, just mirrored. That's the everyday reality of being left-handed in a right-handed world. For most people, right-handedness is like gravity. Invisible, taken for granted, never questioned. But if you're in the 10%, you notice it every time you reach for something that fights you back. Start small. You pick up a pair of scissors. They look harmless, perfectly ordinary. But they aren't. The blades are offset for right-handed use, so that when a right-hander squeezes, the blades press together and cut cleanly. When a left-hander uses the same scissors, the natural angle of the hand pushes the blades slightly apart. The paper bends, the cut frays. To see the cutting edge, you have to twist your wrist into an awkward position. After a while, your fingers ache, your forearm protests, and a simple task has quietly become a minor act of resistance. Can openers do the same thing, but slower? Most classic manual can openers are designed to be held in the left hand and cranked with the right. If you're left-handed, your instinct is to reverse that. Grip with your dominant hand, crank with the other. But when you try, the device flips orientation. The cutting wheel is now on the wrong side, and everything feels backward. You either learn to crank with your non-dominant hand, or you twist your body and the can into some improvised choreography that looks ridiculous and feels worse. Then there are spiral notebooks. If you're right-handed, the metal spiral binds politely to your left, out of your way. You rest your arm comfortably on the page and write. If you're left-handed, that same spiral is no longer neutral. It's an obstacle. Your wrist lands directly on the cold, unforgiving coil. To write a single sentence, you either hover your hand in the air, tense and unsupported, or press down against a row of tiny metal ridges that leave red grooves in your skin. Every line is a reminder that someone else's comfort was the standard, and yours was an afterthought. Even the humble computer mouse can betray you. The default assumption built into decades of office design is that the mouse lives on the right side of the keyboard. The contour of the plastic fits a right hand. The side buttons are placed for a right thumb. In many workplaces, the cable length, desk layout, and cable channels all presume right-handed use. A left-hander can swap sides, remap buttons, or reorient entirely, but that takes time, negotiation, and sometimes a quiet sense of being out of order in a space that was never templated for you. None of these objects are malicious. They're just biased toward the 90%. And for left-handers, this bias shows up in the act that has defined literacy for the last few thousand years: writing. If you live in a culture that writes from left to right, like English, French, or Spanish, the very direction of the script turns against the left-handed writer. Right-handers pull the pen across the page. Their hand follows behind the ink, clean and dry. Left-handers push. Their hand leads. The pen passes, leaves a wet trail, and then the side of the hand moves directly through it, smearing, dragging, blurring. Homework sheets from generations of left-handed children are marked not just with words, but with grey smudges and inky palms. In an age of quills and dip pens, it was worse. Ink dried slowly. To avoid smearing, left-handers had to contort their grip into what teachers sometimes called the hooked hand posture. curling the wrist awkwardly above the line, writing from above and pulling downward. It solved the smearing at the cost of hand strain and long-term discomfort. Many adults who grew up left-handed in the fountain pen era still remember teacher corrections, red marks not just for spelling, but for the way their hand rested on the page. Even ballpoint pens, which dry faster, don't fully break the curse. Whiteboard markers, gel pens, wet notebooks, the glossy pages of standardized test forms all become traps. For millions of people, the incredibly basic act of taking notes is accompanied by this constant micro-negotiation. Angle the page, tilt the hand, slow down, lift the wrist, try to think about the idea while also thinking about the ink. School amplifies the problem. Many traditional classroom desks, especially the single-piece chair and desk combinations, were built with a writing surface attached on the right side, a perfect armrest and writing platform for right-handers. For left-handers, the surface is in the wrong place. Your dominant arm has nothing to support it. You twist your torso, pull your elbow in, or half sit sideways just to get a fraction of desk under your hand. Over the course of years, this posture can quietly shape your neck, your back, the way you sit, and even the way you breathe. Then there are musical instruments. The modern orchestra is a monument to standardization. Violins, violas, cellos, all held on the left shoulder, bowed with the right hand. Not because that's the only way to do it, but because playing in unison requires everyone to move the same way. A left-hander can absolutely learn to bow right-handed. Many do, and some excel. But the first contact between body and instrument is already a negotiation. Adapt to the instrument or stand out and risk being told you are holding it wrong. Guitars offer more flexibility, but at a cost. Left-handed players can choose to play right-handed, reversing their natural dominance, flip a right-handed guitar and restring it, but then all the fret markers and cutaways are upside down, or buy a left-handed instrument, which is often rarer, more expensive and harder to find in small shops or second-hand markets. Drum kits too are usually set up for right-handed players, with a hi-hat and ride cymbal placed to favour a right-hand lead. A left-handed drummer can reverse the entire setup, but walk into a studio or a venue and you may need to reconfigure everything before you can even begin. It's not just artistry that carries this bias, it's risk. Many power tools and machines were engineered with an implicit user in mind, right-handed, right-dominant, with the right hand controlling the main trigger and the left hand stabilizing. Safety guards, emergency shut-off switches, blade rotations. These are often built around that assumption. A left-hander who picks up a circular saw or a chainsaw, for instance, may find that the blade now sits closer to their body, or that sawdust is thrown directly across their line of sight. Switches that would be easy to hit with a right thumb may require an awkward reach with the left. On industrial machines, kill switches and safety levers are sometimes fixed on one side. In a crisis, a half-second of fumbling can matter. Some studies have suggested that left-handers experience slightly higher rates of accidents when using machinery designed exclusively for right-handed use. The reasons are still debated. It might be design bias. It might be that left-handers, forced to adapt constantly, are more likely to improvise grip and posture. Or it might be that environments built for the 90% introduce subtle hazards for anyone who doesn't match the template. You can see the same quiet tension in everyday cooking. Kitchen knives are often symmetrical, but many specialty tools are not. Peelers that only work cleanly when pulled in one direction. Serrated blades with right-handed bevels. Ladles with pouring spouts on one side. Even measuring cups printed to be read easily when held in the right hand. None of these are catastrophic. But for a left-hander, they stack one on top of another into a constant requirement. Adjust, adjust, adjust. Over time, that adjustment becomes a kind of involuntary training program. From early childhood, left-handers live in a permanent state of low-level translation. A teacher demonstrates how to tie a knot with the right hand leading. The left-hander mirrors it mentally and executes in reverse. A textbook shows a right-handed grip on a tennis racket. The left-hander rotates the image in their mind, flipping everything. Video game controls default to the right thumbstick for camera and the left for movement. The left-hander experiments, remapping, mentally reflecting the layout. Psychologists sometimes point out that this constant mirroring may shape cognition. Being forced, day after day, to imagine reversed orientations and adapt movements might encourage a certain kind of spatial flexibility. Left-handers become experts at watching demonstrations performed by people whose bodies are slightly wrong, and then converting those motions into their own mirror image action. It's like growing up bilingual, but in motor space instead of language. The world speaks righty, and you answer in lefty, translating as you go. This doesn't mean left-handers are automatically more creative or more flexible in every domain. Claims like that tend to oversimplify, but it does mean that for many the very structure of daily life is an ongoing puzzle, solved not once but 1,000 times a day. Reach with the other hand, swap the controls, angle the page, flip the device. Adapt. And because the world rarely adapts back, that skill gets sharpened. Yet there are places, quiet corners of the modern world where the bias flips. Step into a specialty left-handed shop, either in a physical storefront or online, and it feels almost uncanny. Scissors with blades reversed, cutting like butter in a left hand. Spiral notebooks with the binding on the right so a left-hander's wrist glides smoothly across the page. Rulers printed from right to left. Kitchen knives beveled for left-handed slicing. Left-handed corkscrews that twist in the direction your dominant hand expects. These objects are not miracles. They're simply the same design logic the majority has always enjoyed, applied in the opposite direction. But for a left-hander encountering them for the first time, there can be a surprisingly deep emotional reaction. Relief, recognition, the sudden sensation that, just for this moment, the invisible architecture of the world lines up with your body instead of resisting it. The existence of these shops is a clue. It tells us that left-handedness is not just a curiosity, but a small market. Small, but large enough to support manufacturers, designers, and whole catalogues of mirrored products. The right-handed majority rarely sees these spaces, just as fish rarely notice the water. But for the 10% they are a reminder that other possibilities exist, that you are not inherently awkward, the tools are simply misaligned. Over the last few decades, awareness of this misalignment has begun to seep into mainstream design. Computer interfaces now routinely allow users to swap mouse buttons, invert controls, and customize layouts for left-handed use. Many smartphones use symmetrical design, making one-handed use with either hand more plausible. Game controllers have evolved with more balanced button placement. Desk manufacturers produce ambidextrous or fully reversible setups. Even some schools now stock left-handed scissors, offer left-handed desks, and train teachers to recognize and support left-handed students instead of correcting them. In certain domains, the change is almost invisible, which is precisely the point. Ambidextrous power tools with central triggers and symmetrical grips reduce the index of bias. Safety switches appear on both sides. Sports equipment brands market left-handed versions of bats, clubs, and gloves as a given, not an exotic niche. In aviation and automotive design, controls are often tested for reach and usability with both hands, if only because emergencies don't respect handedness. The shift is incomplete. Right-handed bias still underlies much of the built world, from musical pedagogy to industrial equipment. In many countries, left-handers continue to encounter subtle pressure to conform, told to switch hands for writing, or given no accommodations in classrooms and workplaces, but the trend line points gently in another direction. a recognition that the 10% are not anomalies to be corrected, but a stable, enduring minority with their own needs, their own advantages, and their own quiet legacy. In that sense, living left-handed in a right-handed world is more than a daily struggle. It's an ongoing, everyday reminder of something evolution has known for a very long time. Diversity doesn't have to be the default to be important. Sometimes, the traits that survive are the ones that learn to navigate a landscape not built for them, turning constant adaptation into a way of life. And in the case of left-handers, that way of life has left marks everywhere, from the smudged ink on ancient school books to the reversed bevel of a specialty knife, to the subtle, invisible rewiring that happens in a brain that must translate the world in mirror image every single day. The first time you really think about it, it feels like a mistake. If evolution is supposed to be ruthlessly efficient, if natural selection is always shaving away anything that causes even a tiny disadvantage, then what on earth is left-handedness still doing here? 10% of the population, everywhere, every continent, every culture we've ever studied. Despite the injuries, the social pressure, the forced corrections, the awkward tools and weapons built for the other 90%. If left-handedness were purely bad luck, purely a defect, purely a misfire in development, it should have been squeezed out long ago, but it wasn't. So tonight, as the world around you winds down and the noise of the day fades, let's sit with this strange number, that stubborn 10%, and ask a quiet but unsettling question. What was so useful about left-handers that evolution wouldn't let them go? To answer that, we need to gather the pieces of the puzzle you've already seen. On one side, there's the fighting advantage. In every sport that mimics close combat, boxing, fencing, wrestling, mixed martial arts, left-handers show up more often than chance would predict. Not a little more often, a lot more often. The rarer they are in the general population, the stronger their overrepresentation in elite combat and confrontation. Why? Because most people train, practice, and live in a right-handed world. Their reflexes, their expectations, their defensive moves are all built around facing right-handed opponents. When a left-hander steps in, angles change. Force comes from the wrong direction. Openings appear where the brain doesn't expect them. A split second of confusion in a fight can be the difference between life and death, between victory and defeat. In a prehistoric world where disputes, raids, and ambushes weren't refereed, that asymmetry might have mattered a lot. Then there's the brain. Left-handers are more likely to have less rigidly separated brain functions. Language, movement, spatial reasoning, emotion, all the things that for most people are strongly locked into one hemisphere, tend to be a bit more distributed in left-handers. Not always, not in every case, but enough that neurologists notice the pattern. That kind of brain wiring isn't automatically better or worse, but it does seem to change the way information flows. It's associated with slightly higher rates of certain learning differences, slightly higher creativity in some tests, slightly different patterns in problem solving, and finally there's genetics. Left-handedness runs in families, but not in a simple, predictable way. There's no single left-hand gene. No neat Mendelian chart. Instead, dozens, maybe hundreds, of genetic variants each nudge the developing brain a little this way or that. Together, in the right combination, they tilt the odds toward a child favouring their left hand. On their own, none of these strands, combat advantage, cognitive differences, genetic complexity, solve the paradox. But woven together, they point toward a very old pattern in evolution, a pattern called balanced polymorphism. And that's where the story finally starts to make sense. Balanced polymorphism is a quiet kind of truce written in DNA. It describes a situation where two different versions of a trait both stick around in a population, because each one has an advantage that depends on how common it is. The classic example isn't about hands at all, it's about blood. In parts of Africa where malaria has been a deadly presence for thousands of years, there's a gene variant that can cause sickle cell disease if you inherit 2 copies. That's a heavy cost. But if you inherit just 1 copy, you don't get the disease, and you gain resistance to malaria. In a malaria-heavy environment, that trade-off is worth it. The gene, with all its risks, stays in the population, balanced between benefit and harm. With left-handedness, biologists suspect something similar is happening, but this time the trade-off plays out in behavior and brains. This idea has a name: frequency-dependent selection. Imagine a world where almost everyone is right-handed. In that world, a left-handed hunter or warrior fights at an advantage. Because most enemies are unfamiliar with their mirrored movements, the rarer left-handers are, the more surprising they become. The more surprising they are, the more often they win dangerous encounters. The more they win, the more likely they are to survive and have children. But now imagine that left-handers become very common. No one is surprised by them anymore. Everyone trains to face both orientations. The rarity advantage fades. Meanwhile, any cost associated with left-handedness, slightly higher developmental risks, possible coordination issues in certain tasks, increased injury in tools built for the majority, start to add up. The result? When left-handers get too rare, natural selection nudges their numbers up. When they become too common, selection quietly nudges them down. Over many generations, this push and pull stabilizes around a certain level, and when researchers look around the world adjusting for cultural pressure, that level seems to hover almost magically near 10%. But if evolution is playing this balancing game, what exactly is it balancing? This is where developmental trade-offs come in. The same genetic and developmental pathways that make left-handedness more likely also seem to change the way the brain organizes itself. They appear to make the brain symmetry more flexible, less locked into the standard pattern. In most people, language lives almost entirely on the left side of the brain. Motor control is strongly lateralized. The architecture is predictable, efficient, specialized. In many left-handers, it's fuzzier. Language might be spread more evenly. Motor skills might be supported by both hemispheres in different ways. The exact pattern can be highly individual. That flexibility could be a blessing or a curse, or both at once. On one side, it might raise the risk of certain developmental disorders, dyslexia, language delays, some forms of epilepsy. These risks are subtle, statistical, not destiny, but they're there in the data. On the other side, that same flexibility might quietly boost creativity, pattern recognition, or the ability to see problems from unusual angles. In a small band of hunter-gatherers trying to survive, the presence of a few individuals who think differently, who solve problems in ways others don't expect, could be incredibly valuable. Not just in fights, but in tool-making, in planning, in social maneuvering. Evolution, remember, doesn't care about perfection. It cares about what works often enough, well enough, to get genes into the next generation. Left-handedness may be the visible tip of a deeper developmental iceberg, a collection of brain-wiring variants that sometimes hurt, sometimes help, but on balance are worth preserving. This isn't unique to hand preference. Human history is full of traits that look, on the surface, like pure vulnerabilities, yet stubbornly remain. Think of the genes for lactose tolerance. For most of our species' history, adults couldn't digest milk sugar. Then, in some cattle-herding cultures, a mutation appeared that allowed people to keep digesting lactose into adulthood. That new ability came with costs, more energy spent on enzyme production, possible links to certain conditions. But the benefit, an extra calorie source in times of famine, was huge. The mutation spread, but not everywhere, and not to everyone. Today, some populations are mostly lactose tolerant, others mostly intolerant. Neither version is universally better. Each works in particular cultural and environmental contexts, or eye color. Blue eyes are more sensitive to light, more vulnerable to certain conditions, yet they persist, especially in regions where lower light levels and other factors made that trade-off acceptable or even advantageous. Left-handedness seems to join this small, strange club. Traits that persist not because they're flawless, but because under certain conditions their benefits outweigh their costs. And one of those conditions is culture. Unlike sickle cell or eye color, left-handedness lives at the intersection of biology and society. For thousands of years, cultures have tried to suppress it, tying children's left hands, striking them when they reach for tools the wrong way, refusing to teach them to write unless they switched, in some places calling it unlucky, in others associating the left side with impurity, with evil, with weakness. And yet, even under heavy cultural pressure, left-handedness never vanished. It dipped, sometimes, in recorded statistics, because people were forced to perform right-handed in public, but the underlying tendency remained. As soon as the social pressure eased, the left-handers resurfaced. That tells us something important. Whatever genetic and developmental processes give rise to left-handedness are deeply anchored. Culture can bend behavior at the surface, but it can't erase the underlying variation. At the same time, culture can amplify or mute the advantages that variation brings. In a society that values close combat, where warriors gain status and reproductive success, left-handers may be particularly favored. In a society that punishes difference, forces conformity, and rigidly controls tools and training, their advantages shrink. In the modern world, the story is changing again. We no longer live in small bands fighting with spears and clubs. Our battles are more often played out in classrooms, businesses, laboratories and digital spaces. The old physical combat advantage matters less. But the cognitive differences, if they exist in meaningful ways, might matter more. A culture that encourages divergent thinking, values creativity, and designs tools and spaces that work for both hands may be accidentally restoring some of the evolutionary balance that used to be maintained on the battlefield. So why does the 10% ratio appear so stubborn, so evolutionarily stable? Because it's probably not about hands at all. It's about maintaining a certain level of behavioral and neurological diversity in the population, just enough to seed unpredictability, innovation, and asymmetry into human groups, but not so much that the developmental costs become overwhelming. Imagine a tribe of 50 people wandering a savanna 30,000 years ago. Most are right-handed. Most think, move, and react in broadly similar ways. But 5 of them, scattered through families and age groups, are left-handed. A bit different in the way they fight, perhaps in the way they learn, in the way they solve problems. When an enemy band appears, when prey behaves in unusual ways, when the weather shifts faster than expected, when an entirely new challenge emerges, that built-in diversity might be exactly what keeps the group alive. Over thousands of generations, natural selection seems to have decided that around 1 in 10 is about right, enough difference to be useful, not so much that the system breaks. And yet, for all these theories, a lot remains unknown. We still don't fully understand how the many genes associated with handedness interact. We don't know exactly how brain wiring patterns linked to left-handedness translate into real-world abilities across different cultures and environments. We don't know how much of the cognitive difference is innate, and how much is the result of living life slightly out of step with a world designed for the other orientation. We don't know whether the left-hand advantage in combat was truly strong enough, over hundreds of thousands of years, to carve that 10% into our species, or whether some other quieter selection pressure did most of the work. What we do know is that left-handedness is old. Very old. It shows up in fossilized arm bones and toolware patterns from long before writing, before agriculture, before cities. It has survived ice ages, plagues, famines, and faiths. It has endured persecution and prejudice, industrialization and mass schooling. It has followed humans into every corner of the planet. The paradox is real, but so is its persistence, which raises one last question. As the world becomes more accommodating, ambidextrous tools, left-handed instruments, flexible teaching methods, will the frequency of left-handedness change? Some researchers think it might rise slightly, simply because fewer left-handed children are being forced to switch, and fewer are experiencing the stress and confusion that came with that pressure. Others suspect the baseline genetic and developmental rate will keep it anchored near that familiar 10% no matter what culture does. We may be living through a quiet experiment, a world where being left-handed carries fewer penalties than at any time in history, a world where left-handedness can express itself more freely, where its potential advantages in creativity, in certain types of learning, in specific crafts and arts, can be explored instead of suppressed. If the ratio shifts over the coming centuries, it will tell us something profound about how tightly biology and culture are intertwined. If it stays the same, it will tell us something just as profound, that left-handedness is not an accident, not a defect, but a carefully maintained minority position written into what it means to be human. For now, as you lie there listening, perhaps with your left hand resting on the pillow or your right hand curled near your chest, you're sharing in that ancient balance, a species mostly one way, quietly, stubbornly, a little bit another, 90% and 10%. Two sides of the same story evolution has been telling for hundreds of thousands of years. The story of left-handedness is really the story of a minority that refused to disappear. Across this episode, we've walked through bones and brains, battlefields and schoolrooms. We've watched ancient hunters surprise their prey with a strike from the unexpected side. We've seen medieval scribes smudging ink across right-to-left scripts, Renaissance painters turning the canvas to match the angle of their strongest hand, schoolchildren in the 19th and 20th centuries having rulers brought down on their knuckles for daring to write with the wrong hand. And yet, through all of that, the numbers never broke. Roughly 1 in 10 humans for thousands of years kept reaching out with the same hand their ancestors used. In caves and cities, in temples and factories, in classrooms and laboratories, 10% quietly persisted. Not a brief anomaly, not a passing glitch, a stable, stubborn feature of our species. Think about what that means. For centuries in many cultures, left-handers faced open hostility. Parents tried to correct them. Teachers forced them to switch. Tools, machines, and weapons were designed as if everyone were right-handed by default. Scissors, desks, musical instruments, writing systems, even the direction of spiral staircases in medieval castles, all tilted against them. It wasn't just inconvenient. For many it was painful, humiliating, and lonely. And still, the trait refused to vanish. That's the part natural selection notices. When something is that costly, yet still doesn't go away, it usually isn't a mistake. It suggests an advantage, even if it's subtle, even if it only shows up some of the time. A hidden benefit that balances the burden. Sometimes that advantage revealed itself on the battlefield or in the boxing ring, when a right-handed opponent misjudged a strike from an unfamiliar angle. Sometimes it appeared in crowded cities or complex crafts, where mixed-handed teams could mirror each other's movements and cover more possibilities. Sometimes it was wired more deeply into the architecture of the brain, nudging creativity, language, or spatial reasoning along unfamiliar paths. Not better, not worse, just different. Left-handedness is a reminder that evolution doesn't aim for uniformity. It aims for flexibility. A population with many ways of thinking, moving, and solving problems can weather more storms than a population in which everyone is the same. Somewhere deep in our species' history, variation itself became a survival strategy, and left-handers are one of its clearest living examples. If you're left-handed, you belong to a lineage that endured both nature's experiments and society's disapproval. Your ancestors learned to write against the grain, to use tools that weren't designed for them, to adapt to a world that kept insisting they were wrong, even when their own body told them they were right. If you're right-handed, the existence of that 10% is still part of your story. They stood beside your ancestors in hunts, in wars, in workshops and families and cities, contributing angles of attack and ways of thinking you might never notice directly, but that still shaped the culture you live in. In a sense, every time a left-hander picks up a pen in a right-handed desk, tunes a guitar restrung to match their grip, or flips a game controller in their own peculiar way, they are participating in a very old negotiation between biology and culture. A quiet insistence. I am part of this species too, and I do things differently. Before we close, if you found this journey through the science and history of left-handedness calming or thought-provoking, you're welcome to support it in a very simple way. You can gently tap like, so YouTube knows this kind of slow, story-driven content matters. You can subscribe if you'd like more history told at this peaceful pace. And if you feel like sharing, you can send this to someone you know who's left-handed, or someone who once tried to correct a left-hander and might see them differently now. I'd love to hear from you as well. Are you left-handed, right-handed, or somewhere in between? Have you ever been pressured to switch hands, or had to navigate awkward tools, desks, or instruments? Let me know in the comments, and, if you're comfortable, tell us where in the world you're listening from tonight. Over time, those comments become a kind of map, a quiet record of left-handers and right-handers listening together, scattered across the planet. For those who want to go a step further, there is an optional channel membership here on YouTube. It's a way to help support the research, writing, and production behind videos like this. Completely optional, of course. Simply watching, relaxing, and maybe drifting off to sleep with these stories is already more than enough. As you settle in, remember this. In a world that repeatedly tried to smooth out every difference, to make every child write the same way, hold the same tools, follow the same line, 10% of humanity quietly resisted. They adapted, they endured, they passed their traits and their stories down through generation after generation. Maybe there's a lesson there for all of us, that sometimes the things that make us inconvenient are the very things that help a species survive, and that in the long memory of our kind there is space, not just for the majority that fits the mold, but for the persistent minority that does not,